Digital and analog outputs. This lesson explores how to use both digital and analog signals to control LEDs. We will start by learning how to make LEDs turn on and off using digital signals. Then, we will learn how to connect multiple LEDs and control each one separately. Next, we will learn how to use analog signals to change the brightness of an LED, creating a smooth fading effect. Finally, we will learn how to mix colors using RGB LEDs, which have red, green, and blue lights that can be controlled to create different colors. Blink an LED with digital output. This program uses a forever loop to repeatedly turn the LED connected to built-in LED IE, pin 13 of the Arduino on and off with a delay of 1 second between each state change. When the LED is turned on, the set built-in LED to high block is executed, and when it's turned off, the set built-in LED to low block is executed. The wait 1 secs block causes the program to pause for 1 second before executing the next block. This creates a blinking effect on the LED. This circuit requires one Arduino Uno, an LED, and a 220 ohms resistor. This schematic shows a simple circuit for controlling an LED with an Arduino Uno. The Arduino's digital pin 13 D13 is connected to a red LED D1 through a 220 ohm resistor R1. The other end of the LED is connected to ground U1_GND. The resistor R1 is crucial for limiting the current flowing through the LED, preventing it from burning out. When digital pin 13 is set to high by the Arduino, current flows through the resistor and LED, causing it to light up. When the pin is set to low, the current stops and the LED turns off. This is a basic setup often used for testing and demonstrating digital output on Arduino boards, as many boards have an onboard LED connected to pin 13. To develop an electronic circuit, please follow the steps outlined below. In the Components panel, drag a resistor and LED onto the workspace. Edit the resistor's value by adjusting it to 220 ohms in the Component Inspector, which appears when the resistor is selected. Back in the Components panel, find and bring over an Arduino Uno board. Click once to connect a wire to a component or pin, and click again to connect the other end. Connect your resistor to either side of the LED. If you connected your resistor to the LED's anode, positive, longer, connect the resistor's other leg to Arduino's digital pin 13. If you connected your resistor to the LED's cathode, negative, shorter leg, connect the resistor's other leg to Arduino's ground pin GND. Create another wire between the unconnected LED leg and pin 13 or ground, whichever is still not connected. To develop the block program, click the Code button to open the code editor. Select Output and Control categories, respectively, and drag the following blocks in Forever container in given order. Set built-in LED to high. Wait 1 secs. Set built-in LED to low. Wait 1 secs. Click Start Simulation to test your code. You can view the block code and equivalent C++ code here. Multiple LEDs and breadboard. This program uses a forever loop to repeatedly turn the LED on breadboard through built-in LED pin of the Arduino on and off with a delay of 400 milliseconds between each state change. When the LED is turned on, the set built-in LED to high block is executed, and when it's turned off, the set built-in LED to low block is executed. The wait 1 secs block causes the program to pause for 1 second before executing the next block. This creates a blinking effect on the LED. This circuit requires one Arduino Uno, 3 LEDs, and 3 220 ohms resistors. This schematic shows 3 LEDs connected to an Arduino Uno. Each LED, D1 red, D2 yellow, D3 green, is connected in series with a 220 ohm resistor, R1, R2, R3 respectively, to a digital pin on the Arduino. D13 for the red LED, D12 for the yellow LED, and D11 for the green LED. The other end of each LED is connected to ground, U1_GND. The resistors limit the current flowing through the LEDs, protecting them from damage. This setup allows the Arduino to independently control each LED by setting the corresponding digital pin to high to turn the LED on or low to turn the LED off. To develop an electronic circuit, please follow the steps outlined below. Pick out components from the Components panel to add to your workspace similar to the circuit shown. Create wires connecting Arduino's 5V pin with the red plus power rail on your breadboard, and likewise GND with the black ground rail. To change your wire colors, select the color in the inspector, or use the number keys on your keyboard to quickly switch between colors. Wire connections to 5V are typically red, and those connected to ground are black. Position your LED so the legs go to 2 different rows of the breadboard. Attach wires to any of the holes in the same row to make an electrical connection. Just like before, we want to connect the LED and resistor in series to pin 13 and ground. Add a few more LEDs to this circuit, along with their companion resistors. For each, connect one end to ground and the other to a different digital input pin on the Arduino board. To develop the block program, please follow the steps outlined below. Click the Code button to open the code editor. Click on the Variable category in Blocks panel and create a variable animation speed with your desired time in milliseconds. Select Output and Control categories, respectively, and drag the following blocks in Forever container in given order. Set built-in LED to high. Set pin 11 to low. Set pin 12 to low. Wait animation speed milliseconds. Set built-in LED to low. Set pin 11 to high. Set pin 12 to low. Wait animation speed milliseconds. Set built-in LED to low. Set pin 11 to low. Set pin 12 to high. Wait animation speed milliseconds. Click Start Simulation to test your code. You can view the block code and equivalent C++ code here. Fading LED with analog output. Pulse Width Modulation, PWM. PWM stands for Pulse Width Modulation. It is a technique used in electronics and digital control systems to control the average power delivered to a device by varying the width of the pulse in a pulse train. PWM is commonly used to control the speed of motors, the intensity of LEDs, and various other applications where precise control of power or voltage levels is required. By changing the duty cycle, the percentage of time the signal is high, PWM can effectively regulate the output and achieve a desired level of control. The Arduino board can only generate digital signals, high and low. However, through the analog write function, we can simulate the appearance of varying brightness between on and off using PWM-capable pins. PWM works by creating an oscillating digital signal, alternately driven high and low in a repeating pattern. Each high to low to high period of time is called a cycle. The duty cycle of a PWM signal is the fraction of time that the signal is high during each cycle. This code creates a fading effect on an LED connected to pin 9 by counting up and then down in increments of 5, with a 30 millisecond delay between each change in brightness. The analog write function uses PWM to simulate varying brightness using digital signals. This circuit requires one Arduino Uno, an LED, a resistor, and oscilloscope. You can view the Arduino Uno schematic here. Let's learn to adjust an LED's brightness using one of the Arduino's analog outputs. You already learned how to use Arduino's digital I/O pins to send high and low signals to an LED, but some of these pins are capable of simulating a signal somewhere in between. These pins are labeled on the Arduino Uno with tilde symbol next to the pin number. To develop an electronic circuit, please follow the steps outlined below. Identify the LED, resistor, and wires connected to the Arduino in the Tinkercad Circuits workspace. Drag an Arduino Uno and breadboard from the Components panel to the workspace, next to the existing circuit. Connect breadboard power, plus, and ground rails to Arduino 5V and ground GND, respectively, by clicking to create wires. Connect the LED cathode, negative, shorter leg, to one leg of a resistor. Anywhere from 100 to 1K ohms is fine. Connect other resistor leg to ground. Connect LED anode positive longer leg to Arduino pin 9. To develop a block program, please follow the steps outlined below. Open Code Editor. Click on the control category and drag out the Count Up by code block. Set it to Count Up by 5. Click the drop-down next to 4 and select Rename Variable. Then rename it to Brightness. Adjust the From and to values to 0 and 255, respectively. Inside the counting loop, add an analog output code block, set pin 3 to 0, and adjust it to pin 9. Navigate to Variables and drag the brightness code block to the output code block to replace the 0, to set pin 9 to the current value of brightness, which changes over the course of the counting loop. Add a wait code block, also in the control category, and set it to 30 milliseconds. This gives time for the light to shine at each brightness level, so you have time to see it before it changes. The duration of this code block can be changed to slow down or speed up the fading effect. The counting loop you created fades the LED from off to all the way on. To fade the LED back off again, we have to create another counting loop. Either drag a new counting loop into the editor or duplicate this one. Right-click, and this time change it to countdown. Start with 255 and go down to 0. You can view the block code and equivalent C++ code here. RGB LED Color Mixing. This code uses a forever loop to repeatedly set the color of an RGB LED connected to pins 11, 10, and 9 on the microcontroller. This circuit requires one Arduino Uno, one RGB LED, and three 220 ohms resistors. You can view the Arduino Uno schematic here. Electronic circuit. Please follow the steps outlined below. Add an Arduino and breadboard alongside the sample and prepare your breadboard by connecting Arduino 5V to the power rail and Arduino GND to the ground rail. Add an RGB LED from the component storage box and place it across 4 different rows of the breadboard. The RGB LED has a common cathode negative ground at its second leg, so wire this row/pin to ground. Add 3 resistors and move them to the breadboard rows for the remaining 3 LED pins. Connect wires from the free resistor ends into 3 of your PWM-capable Arduino pins, which are marked with a tilde, little squiggle. To develop the block program, please follow the steps outlined below. Click the Code button to open the code editor. Select Output and Control categories, respectively, and drag the following blocks in Forever container in given order. Set RGB LED in pins 11, 10, 9 to cyan. Wait 1 second. Set RGB LED in pins 11, 10, 9 to magenta. Wait 1 second. Set RGB LED in pins 11, 10, 9 to yellow. Wait 1 second. Click Start Simulation to test your code. You can view the block code and equivalent C++ code here.